Okay, this one might be hard to get done in 15 minutes. I'm gonna try and get better at this. I don't want to have two parts. So I'm gonna just not tell you guys to pause me from now on. So just pause me to write stuff as we scroll. So this notation with the kind of bracket is just a matrix. Okay, we're gonna learn a new notation that doesn't have the little hooks or legs or whatever you want to call it. It looks more like an absolute value. This is actually giving you an instruction to find the determinant. And we'll talk about what the determinant is in like 2 seconds. So I could just give you this as a problem with no words, and that would be telling you to find the determinant, okay? So here's what the determinant is. For a 2 by 2 matrix, we crisscross applesauce. I don't know why I just said that. Oh, I forgot to turn my pen on. So we multiply A times D, and then we subtract B times C. That's for a 2 by 2 determinant. And for a 3 by 3 determinant, which I didn't write, this is a 3 by 3. It's a little bit more involved. So instead of explaining what it is here, I'm going to explain it in a problem. Okay? Actually, am I? No, I'm not. So I'm going to explain it here. I wrote these notes a while ago, so I'm going to explain it here. So when we're doing a 3 by 3 or higher determinant, we start with the top left entry, so the A, and then to get this thing right here, we eliminate a row and a column that include A. So the EFHI, see how that matches right there? Okay. Then we move over and we do B. Oops, I did not mean to erase the B. And then we move over to B, okay? And we'll talk about the signs in a minute. We eliminate the row and the column that B is in, and you'll see DG and FI are left. That's where that comes from. Then we move over to C. So we have C next in our equation. We eliminate the row. I just erased it all. This is what happens when I'm trying to go quick. I'm not paying attention to the writing utensil. So we move over to C. That's where the C is in front, right? We eliminate the row and the column that C is in, and we have D, E, G, H right here. And then we can go through and do what we did up here. So we're going to multiply EI minus FH minus B times DI minus FG plus C times DH minus EG. And you'll notice that the A is positive, and then the B is negative, and then the C is positive. So positive, negative, positive. Okay? And then you would just, these are all going to be numbers, so you would just calculate that. So Cramer's rule is another way to solve linear systems because we don't have enough ways to solve linear systems yet, right? So these are the ways we find the values of x, y, and z. And then we're talking about a system that looks like this. So the d in the denominator of all three of these is just the determinant of the coefficients of x and y. The d sub x, we're going to replace the x column. So we keep the b and the d the same as the original. And then we replace the x column with the answers in the equation. And then for the y, we replace the y column. So let me write a note. Replace x column for the x value, for the d sub x, and then replace y column for the d sub y. So I'm going to find a different color. I'm going to leave the X column alone, and I'm going to replace the Y column with the E and the F. So let's do an example of that. Okay, so let's keep this up right here. And I'm going to go, D is just the coefficients of the X's and the Y's. So 1, 1, 2, -1. And then I multiply across, minus, multiply across, so I get -3. For the D sub X, I replace the X column, I leave the Y column alone. And then I multiply across, minus, multiply across. And then for the D sub Y, I replace the Y column, and I leave the X column alone. Multiply across, minus, multiply across. And then scroll back up and look, the X is the D sub X over D, the Y is the D sub Y over D, and if there was a Z, it would be D sub Z over D. So I'm going to say X is -11 over -3, and Y is -2 over -3. So my answer is 11 over 3, comma 2 over 3. Okay? All right, so let's look at this now. If any two rows or columns of a matrix are interchanged, their determinants are, let's fill in the blank, okay? So the pink is like my example of showing you that I have a matrix, and then below it I have a matrix where I've interchanged the rows. So let's look at what happens. I go AD minus BC up here. And on this one, I have BC minus AD, which is the same as that. So pause me and think about what the relationship between those two values is. Okay, hopefully you said opposites. Okay, if all entries in any row or column are 0, then the determinant is, you can probably figure this out just by looking at it, right? If I go multiply across minus multiply across, I end up with 0. Okay? If any two rows or any two columns of a matrix have equivalent entries, then, so do you see, now I'm showing rows having equivalent entries and another row having equivalent entries. So 2 rows or 2 columns have equivalent entries. So I want you to try this one on your own. So pause me and do this one and fill in the then part. Okay, so AC minus AC. I guess I left off more on this one than the previous ones. The determinant is 0. I can't write. That's a 0. Sorry, it's kind of messy. Okay. And then if any row or any column of the matrix is multiplied by a non-zero number, then the determinant is. So again, I want you to figure out what these two values are, the value of this determinant and the value of this determinant, and see if you can fill in that blank. So here we have AD minus BC, and then here we have NAD minus NBC. Now I feel like I'm watching TV. Oh, sorry, bad joke, NBC. And then you might be able to see it better if you do factoring out, take out an N. So the determinant is just multiplied by the same number, the same non-zero number. Okay? All right, well, that was shockingly short. I was worried about it being 15 minutes and it's under 10. So hopefully you paused me a lot to write things down and soak things in, okay? All righty, see you next time.